My dear student, how are you? I think all of you are well, staying at home. So, welcome to our Pashala presented by Manipur Uchcha Vidyalaya and College. Just see a figure in the slide, what you are seeing. This is a common picture in our daily life. So, easily you can guess what we are going to learn today. Yes, my dear student, you have things right. Today we are going to learn about current electricity. So, our today's topics: Ohm's law and resistance, chapter 3 current electricity, lecture 1 physics second paper for the classes 11 and 12. Learning outcomes. At the end of the lecture, the student will be able to know why does electron flow from one point to another point in a conductor, what is resistance, and why resistance of different materials are different, and what are the different density of resistance, and finally, they will be able to solve some mathematical problems that helps them to prepare in the examination. So, the name of the chapter is current electricity. So, I am interested to give the definition of current electricity. The flow of electrons in a conductor is called electricity or current electricity. From this definition, so many questions you can arise. Number 1, from where these electrons come, and why does electron flow from one point to another point in a conductor? And third one, at what velocity the electron will flow? Now, let us know the answer of these 3 questions. Then the definition of current electricity will be clear to you. So, first question is, from where electrons come? And this electron is ordinary electrons or something else. Basically, these electrons are known as free electrons. So, what will be the definition of free electrons? Electrons of the outermost shell of atoms like silver, copper, aluminum, etc. are loosely bounded with the nucleus of the atoms. So, these electrons can be easily detached from atom, and these electrons are called free electrons. You have learned Bohr model, Rutherford atom model, or you know electron configuration. From this conception, you know that 1 or 2 electron exist at the uppermost shell of an atom, and these electrons are loosely bounded with the nucleus. So, by supplying less amount of energy, you can easily detach this electron from the nucleus, and these electrons can move easily through the metals, and this electron is known as free electron. Basically, these electrons create electricity. Number 2, why electron flow from one point to another point in a conductor? Suppose this is a conductor where A is the lower potential and B is the higher potential. If there is a potential difference between 2 terminals, that is A and B, if there is a potential difference, then electron can flow from lower potential to higher potential. That means, in this case electron will flow from A to B, that is from A terminal to B terminal. For your kind information, when electron goes from A to B, then conventionally we think current flow from B to A. So, this is the conventional rule. The opposite direction of the flow of electrons is regarded as the direction of flow of current. Now, last question is that at what velocity or speed electron will flow? Do we know the velocity at which electron flow from lower potential to higher potential? And this velocity is known as drift velocity. So, what will be the definition of the drift velocity? During the flow of electric current, the velocity with which an electron moves from lower potential to higher potential is called drift velocity of free electrons. That means, the velocity at which free electron moves to make current, to make electricity is known as drift velocity. And now, you have already learned why electron flow and the flow of electricity causes the electricity, a flow of electron causes the current or electricity, but is there any relation between the velocity of these electrons, that is the relation between the drift velocity and current? Of course. Now, I am going to discuss about the relation between current and the velocity of electron. Like as before, we just have taken a conductor having lower potential A and B is the higher potential, and these are the electrons. You have already note electron goes from A to B terminal. Now, let us consider the drift velocity of this electron is a small v. And now, how many electrons exist in the conductor? Let us think. Number of electrons in unit volume is a small n. And now, the cross sectional area of the conductor is A, and consider the electricity flow through this conductor, that is the value of current is I. Now, how many electrons flow in a small time dt through any cross sectional area of the conductor, that is the distance travelled by free electrons in time dt equals to L equals to V into dt. You know, this is a simple relation, S equals to Vt, S equals to Vt. In this case, V is V and T denoted as dt as we consider very small time. So, this is the travelling distance by the electrons in a small time dt. Now, how many electrons will flow within this small time? You know that if we consider n is the total number of electrons of the conductor, then n will be equals to a small n multiplied by v, where v is the volume of the conductor. This is not the velocity, this is the volume of the conductor, and you know that volume equals to area into length, that is area, and L is replaced by V into dt. That means, you can write n V equals to n equals to n V, B equals to A L, where L is considered as V into dt, n A V dt. This is simply. Now, we have already learned the electron charge of an electron is a small q. So, what will be the charge of these electrons? Just you have multiplied q by this number, you will get the total charge of the electrons that is flowing through in dt time through any cross sectional area, that is dq equals to n A q v dt. So, this is the amount of flowing charge through any cross sectional area in time dt. Now, we know that current I equals to dq by dt. Now, putting the value of dq in this equation and cancelling dt, then you will get n A q v. So, this is the equation of drift velocity related to current. If you want to calculate the velocity, drift velocity, then you will write v equals to I by n A q. So, this will be the equation of drift velocity. So, another answer of the question has gone. Now, we have learned if potential difference is maintained, then electron will flow. Now, my question is, does the potential difference is maintained automatically or some other cause? That means, potential difference is maintained necessarily or automatically? No. My dear students, to maintain this potential difference, you have to use an electromotive force, that is, you have to use a battery or cell. As long as the battery can maintain the potential difference, you will get that time. So, we have learned if there is a potential difference, then the electron will flow from lower potential to higher potential, that will create current. So, is there any relation between the potential difference and current. Question is coming after answering one question after another question. So, this is another question, is there any relation between the current and potential difference? Yes, of course. This can we know from using Ohm's law. So, what basically says in Ohm's, a prominent scientist, at constant temperature the current flowing through a particular conductor is directly proportional to the potential difference between two ends of the conductor. That means, basically Ohm says maintain constant temperature, potential difference is directly proportional to current. Now, I am going to explain this. Suppose this is a conductor and having a terminal potential V A and the B terminal is potential V B and the flowing current is I. Now, if V A is greater than V B, V A is greater than V B, then potential difference you can easily write V equals to V A minus V B. So, this is the potential difference. Now, from Ohm's law you can write I proportional to V. So, this is the Ohm's law, and when you write proportional equals to in place of proportional, then you have to write a constant, and in this case G is that constant. So, what is G basically? G is a constant of proportionality, is known as conductance, and the reciprocal property of G is R, where G equals to 1 by R. If we place 1 by R in place of G in this equation, we will get I equals to V by R. So, this is the mathematical expression of Ohm's law, and from this law you can easily understand that with the increase of potential difference current will be increased. But there is also two new variables in front of you, one is capital G and another is R. Now, if we plot potential difference versus current electricity, we will see a graph like this. That is, you are going to get a graph that is passing through the origin. So, a straight line passing through the origin. From this graph you will very clear that with the increase of potential difference the current is increases, and from the slope of this graph you can easily know the constant, that is R, the resistance. From Ohm's law you know that R equals to V by I. So, this is the variable constant, you know that, and this is known as the resistance. You know that resistance is the property of the conductor that forbid to flow electricity, that discourages to flow electricity through the conductor. So, this is the opposing property of the material that forbid or hinders to flow electricity. Now, what will be the unit of resistance? That is volt per ampere, that is known as omega, the symbol of resistance. You know the unit of resistance is basically ohm. And now, another question for you, some figures or images of resistance that are widely used in different instrument, like this is the symbol of the images of resistance that we see in different devices in our daily life. Now, what is meant by resistance of a conductor 5 ohm? What is meant by the resistance of a conductor 5 ohm? As our earlier slide, you know that R equals to V by I. That means to create on V by I, that is to, if there is a potential difference between two ends of a conductor is 5 volt, then 1 ampere current can flow through the conductor. That is V equals to IR or R equals to V by R, that is 5 volt by 1 ampere. This is if that means in order to flow 1 ampere current, if there is required 5 volt potential difference, then the resistance of the conductor will be 5 ohm. Now, we are going to discuss another constant, that is conductance. From Ohm's law you will easily know that I equals to Gb, then G equals to I by V, that is current by potential difference. So, what will be the unit of conductance ampere per volt, and this is simply known as S, where S basically denotes the Siemens, the unit of conductance, the property that helps to electricity through the conductor. Now, what is meant by the conductance of a conductor of 1 Siemens? 1 Siemens, what does it mean? That means, in order to create, you know that I equals to GV or G equals to I by V. That is, if you create or if you want to flow 1 ampere current by supplying 1 potential difference 1 volt, then you will get 1 Siemens. That means, the potential difference between two terminals of a conductor is 1 volt, through where if 1 ampere current is flow, then the conductance of the conductor is 1 Siemens. Now, we have learned two variables, two constant, that is, one is resistance and another is conductance. Now, resistance is the opposite property to flow electricity. That is why I am interested to discuss about the dependency of resistance. That is basically what basically depends on resistance. You know that 4 factors basically depends on resistance. That is, resistance depends on this quantity. Number 1, the length of the conductor. That means whether the length of the wire of the conductor is shorter or longer, basically defines resistance. And the cross sectional area of the conductor, that means whether the conductor is thick or coarse. Number 3, the metal of the conductor, that means in which metal you are using as conductor, like you can use silver, aluminum or gold. And number 4, the temperature of the conductor, that means at what temperature you are doing your experiment, you are flowing through a current. Now, this dependency can be easily explained with the help of the laws of the resistances. Now, I am going to discuss the laws of the resistances. The first law is known as the law of length. You know that, my dear student, when you are going to discuss about the law of length, then the rest of the 3 component of the dependency must be constant. That is, temperature of the conductor should be constant but remains constant, cross sectional area of the conductor remains constant, material of the conductor should be remain constant. If all these 3 constant are remain constant, variables are remain constant, then you will get resistance is directly proportional to length. That means, the more the length of the conductor, the more the resistances. From this equation, it is clear that longer wire has more resistance than the shorter wire. And number 2, the second law, laws of cross sectional area. Similar condition in this case, the constant quantities are temperature and the length, and third on the material. Then, if these 3 quantities or dependency are remain constant, then resistance is inversely proportional to its cross sectional area. That means, the more the cross sectional area, the less the resistances. And number 3, the law of material. Similar condition, temperature remain constant, cross sectional area of the conductor remains constant, and length of the conductor remains constant. If these 3 conductance remain constant, then the resistance of the conductor depends on the material. That means, in which material the conductor is made, whether it is made gold or silver or aluminum. But you can write this quantity with the help of mathematical equation, and that is R equals to rho L by A, where L and A both are variable. And here rho is the specific resistance. Basically, this rho explain the property of the conductor. Now, the last one is temperature dependency of resistance. We have already discussed the 3 variables or the 3 dependency. Number 1, the length, the cross sectional area, and the metal, and the last one is temperature dependency. That means, if you increase the temperature of the conductor, the resistance will be increase or decrease. You know that metal is composed of large number of molecules, and these molecules are always in vibration. So, when free electrons move through the conductor, these electrons collides with the atoms of the molecules. if you increase the temperature, then this vibration will increase at a greater rate with greater amplitude. So, who is resulting that makes the large number of collision. That means rate of collision will be increases. That means resistance will be increases only for the conductors. And for the semiconductors, with the increase of temperature, resistivity will be decreases. You know that there is no electrons in the conduction bands in the semiconductor. That's why with the increase of temperature, number of conducting electrons will be increases, and that's why for semiconductor, with the increase of temperature, resistance will be decreases and conductance will be increases. Now, I am going to discuss about relation of temperature with the resistance. Let us consider the resistance of a conductor at 0 degree Celsius is R naught and at theta degree Celsius is R theta. So, what will be the increase of resistance, and for 0 degree for theta degree increased temperature, resistance will be increased by R theta minus R naught. The temperature difference is theta minus 0, that is theta degree, and this is the increase of resistance. Then simply you can write R theta minus R naught is proportional to R naught theta. This is thermometric property also, and then you can write R theta minus R naught equals to constant into R naught theta. You know that, and this constant is here is alpha, and just I have write in a simple line by changing side sense R theta equals to R naught 1 plus alpha theta, where alpha is the constant and is know that, and this constant is known as the thermometric is known as the temperature coefficient of resistivity. That means if temperature increases, then resistance will be increased, then in this case alpha is considered as positive. That means if alpha is positive, that means resistance will be increases, and if alpha is negative, that means resistance will be decreases. Now, what is the unit of this component constant, that is per degree Celsius or per Kelvin? This is the unit of temperature coefficient of resistance. Now, what is mean by temperature coefficient of resistance of manganese of 3 into 10 to the power minus 5 per Kelvin? What does it means? Temperature coefficient of resistance of manganese of 3 into 10 to the power minus 5 per Kelvin means if the temperature of manganese conductor having 1 ohm resistance at 0 degree Celsius is increased by 1 degree Celsius, then its resistance will be increased by 3 into 10 to the power minus 5 ohm. That means temperature coefficient of resistivity basically describes what amount of resistance is increased due to increase of 1 degree Celsius on unit resistance of 0 degree Celsius. That means in this case the resistance is 1 ohm at 0 degree Celsius, and when temperature will be 1 degree Celsius, then resistance will be 1 plus 3 into 10 to the power minus 5 ohm. That means resistance will be increases depending on the resistance of 1 ohm having temperature 0 degree Celsius. Now, we are going to see a graph temperature versus resistance or resistivity. This is the x-axis is considered as temperature, and this is the y-axis, and this is denoted by resistance. If you put the proper information, then you will get a graph like this. That means with the increase of temperature, resistance is increases, or inversely you can say with the decrease of resistance, with the decrease of temperature, resistance is decreases. But when temperature is 0, the resistance does not 0. That means a material does not have 0 resistance at 0 degree Celsius. But if it is possible, that means if the resistance of a conductor becomes 0 at low temperature, then this conductor is considered as superconductor. This is the superconductivity, and you know that like this portion basically denotes due to minus temperature the resistivity of the material becomes 0. That means in this point the material or the conductor behaves as the superconductor, and you know that the recent world basically depends on the superconductor. By using superconductor, high magnetic field we can produce, that is widely used MRI MRI and widely used in maglev trap for superconductivity and for the research. These are widely used. In 1911, first scientist Owens has seen this with the increase of due to temperature falling, the resistance becomes falling. And an example for your simply manner I can place here, that is for lead at 7.25 degrees Celsius. That means at 7.25 degrees Celsius, the resistivity of lead becomes 0. Now, do some mathematical problems. This is the problems for you. This is the iron having resistance 0 degree, 4 ohm at 0 degree Celsius, and at 100 degrees Celsius, the resistance is 6.5. Then you have to calculate the temperature coefficient of resistance. That means you have to calculate alpha. So, what are the given information? Number 1, resistance at 0 degree, 4 ohm, and resistance at 100 degree, R theta equals to 6.5. So, what is the increase of temperature? That is 100 degree minus 0, that is 100 degree Celsius, and you can write difference can be easily write degree Celsius is equals to Kelvin. For only difference you can write this. Now, you have to calculate temperature coefficient of resistivity, that is alpha. Then by using a formula that we have learned, R theta equals to R naught 1 plus alpha theta. By rearranging this, alpha equals to R theta minus R naught by R naught into R theta. Putting all these variables, value of all these variables, you will get 6.25 10 to the power minus 3 per Kelvin. So, this is the temperature coefficient of resistance. Now, just we have reached at the last of our class, and a simple homework for you, and this is 2 problems are available here. Number 1 is related to temperature coefficient of resistivity, and number 2 is related to resistance, that is a specific resistance R equals to rho L by A. This simply equation says that the first problem says that temperature, when temperature is 25 degrees Celsius, the resistance is 65 ohm, and when temperature is 100 degrees Celsius, then you have to calculate the resistance, and your given information is the temperature coefficient of resistance 5.1 into 10 to the power minus 3. In order to solve these problems, you can easily in 2 ways, you can use 2 ways. Number 1, by using forming 2 equation, or by calculating the resistance as 0 degrees Celsius. And number 2, a bronze wire of 15 ohm is elongated in such a way that it becomes 4 times in length and its area of cross sectional becomes 1/4, then find its resistance. This problem is related to R equals to rho L by A. R equals to rho L by A, and these relation are given here, that is what will be the L2 and what will be the A2. This is simply written here 1/4 times area and length will be 4 times, that is L2 equals to 4 L1 and A2 equals to 1/4 A1, and if you use this, then you will easily find the value of R2. So, no more today. Thank you for joining with us. Thanks again.